Today let's go over a easy question that I solved a while back, 4 months ago. This one is called check if all integers in a range are covered. So you're given a 2D integer array and two integers left and right, and you want to include or return true if each integer is in this range, and then return false otherwise. So the inclusive is defined as being greater or less than or equals to. So equals to counts as being included. So cool. So basically we want to iterate over our 2D array. And let's make this easier by saying A and B to unpack it. So we get 1 and 2, 3 and 4, 5 and 6. And then let's just ask the question, if not, left is less than or equal to A is less than or equal to B, return false. If not, right is less than or equal to A, or let's do it like this. Left. So left is in between A and B in terms of value. Then return false. In the end, we can probably just return true, right? So if either or are false, then it's false. Okay, that's not correct. Let's see. By at least one interval in ranges. Okay, so let's do this. Left count and right count equals to 0, 0. So once both of the counts are at least 1, then we'll be good. So if A is less than or equal to left is less than or equal to B, then left count plus equal to 1. If A is less than or equal to right is less than or equal to B, right count plus equal to 1. And then return left count is bigger than 0 and right count is bigger than 0, because there will be at least 1. Then you know that they're all covered. Okay, so some edge cases here. Okay, so 29 looks like it's not covered because of interval, at least one interval. Okay. So left is not in here, left is not in here. Left is in here though. Okay. Let's print A and B to make sure. That's fine. If A is each interval or each integer is covered by at least one interval. Okay. Maybe let's just call this result. False. I'm thinking something like that. Nope. Okay. Then left count, right count, 0, 0. Left count plus equal to 1. Let's go back to our old design. Left count is bigger than 0 and right count is bigger than 0. I'm surprised that doesn't work because here... Okay, so 37 and 49, so left is not in between that. Okay, so they're both 1. Okay, so yeah, they're at least covered by 1. In this case, it doesn't... It looks like this is still covered, though. Yep, start less than or equal to x, less than or equal to n. That's fine. 29 is covered here. 49, or yeah, is covered here. Why is this false? If each integer in the inclusive range, oh, each integer, okay. I see, okay. So let's say this is good. At least one interval. Okay. Okay, so for I in range left to right plus 1, now we're going to go from 2 to 5. And if A is less than or equal to I is less than or equal to B, then good dot append A, or good dot append I. Let's print good, and we want to see if 2, 3, 4, and 5 are inside of it or not. So that's fine. Okay. So now we can go over good. If G is less than right and G plus 1 is not in good, then we can return false. If G is bigger than left and G minus 1 not in good, return false. Otherwise, you return true. We're just checking if they're contiguous. Okay, so if not good, return false. There you go. So it passes all test cases. This was actually a bit of a challenge, but basically just reading the instructions carefully, making sure every number between left and right inclusive is covered in at least one of these intervals, and returning false if even one of them doesn't appear. Like for example here, 36 doesn't appear, 33 doesn't appear in any of this, so then we return false. If that's never returning false, then we return true at the end. So hopefully this is helpful, and thank you for watching, and stay tuned for more.